Hello, thank you for joining us on this session. I'm going to be looking specifically at hyperbolas in this session. And what I'm going to be looking at is, first of all, let's get to know a hyperbola a little bit better, which is the y equals k over x function. And at the end, let's do a translation where we slide it 1 unit, and we're going to slide it to the right in this session. And we'll look at just the domain and range at the end. Well, when we have a function like this, I'm going to see that x. Some students don't realize this is simply also a product of the x and y coordinates, and we get a constant. So if our products equal to 4, let's say we multiply the x and the y coordinate and get a constant value of 4, that's the same as the function y equals 4 over x. Here the constant's 4. Let's look at the graph of this, and we'll take the 4 quadrants, quadrant 1, and let's look at some points in quadrant 1 where the coordinates multiply to equal 4. Well, first of all, the square root of 4 times the square root of 4 equals 4. So the square root of 4 times the square root of 4 equals 4, and that's taking the x coordinate, multiplying by the y coordinate, and letting it equal to 4. That's 2, 2. So 2, 2 equals 4. Another coordinate is 4, 1. So 4x and 1 is a y. They multiply to equal 4. Another coordinate is 1, 4. 1, 4 equals 4. Now we could get a half times 8, we could get 8 times a half, and eventually all of those points, when you graph them, you're going to get this hyperbola in the first quadrant. Now there is another quadrant where we will also get 4, and that is quadrant 3, because negative 2 times negative 2 is also 4. So a negative times a negative will always equal a positive. So we're getting a positive value. So we're dealing with the coordinates in quadrant 1 and in quadrant 2. So negative 4 times negative 1, negative 4, negative 1. So negative 4 times negative 1 also equals 4. And we've got negative 1, negative 4. And you can see that we're going to get the same shape on our graph, and it's hyperbolic shape, and that's going to run along, that's going to eventually run along the, let's just tidy this little piece. So that's going to run down on the, through that point and run down. That's the point negative 4, negative 1, negative 4. And there is our graph of the hyperbola. Now, of course, if we changed our constant, if it was 9, we would get 3, 3, etc. So if we changed our coordinate x, y equals 1, we would get 1, 1, and we would get a tighter little hyperbola in here. Okay, I'd like to take this and slide it 1 unit to the right. So that means we're going to translate this. So it's a translation. So translate this function 1 unit to the right. Now, how will that affect our equation? This will become y equals 4 over, and it was x. This is like a parent function up here where we have no translations whatsoever. And let's translate 1 unit to the right. So it's 1 unit to the right. We put a minus in here. If it was 1 unit to the left, that, in fact, yes, would be a positive 1. Where would that graph go? 1 unit to the right. So instead of 2, 2, it would go across to 3, 2. And instead of 4, 1, it would go across to 5, 1. Instead of 1, 4, it would go across to 2, 4. Instead of negative 2, 2, it would go across to negative 1, negative 2. Negative 1, it would go across to 0, negative 4. This would go across to negative 3. Now that graph would then if you sketch that graph, it would come down through here. And it would come down through here, just drawing that here. And what will happen is you get a vertical asymptote which has moved across from the y-axis to the x equals 1. And that becomes the vertical asymptote for this graph down here. Before, the vertical asymptote was in fact the y-axis, the x equals 0. And let's have a look at the domain of this function and the range of this function. The domain are the possible x values that we're dealing with. So it's the set of x being an element of the real set such that x cannot equal 1, because when x is 1, the denominator would be 0, and then you can't have that. Now the possible y values will be, you can see it's in fact all y values except, notice the graph will never touch the x-axis, so y will never be 0. And so there is a set of x values, which the set of domain, which is in fact the set of the possible x values, and the range is the set of possible y values. And if there's a restricted y value, you can put what y is, but in this case we're putting what y isn't. Y can't equal 0, and for the range, for the domain, x can't equal 1, and for the range, y can't equal 0. Well, I hope that this has helped. We've introduced the topic, we've looked a little bit about hyperbolas, which is in fact like xy equals some constant, but often it's written as y equals k over x. So that's a function of x can be k over x, which is a different way of writing a hyperbola. And we've also translated 1 unit to the right, so this becomes x minus 1 instead of x. And so we can see just by looking at this hyperbola that our vertical asymptote is moved from the y-axis across to the x equals 1 line. I hope this has helped. It's an introduction into hyperbolas. Until next time, stay happy.